if I multiply this times this, can I ever get a positive number? Because what has to be true about these signs? They have to be opposite, right? They have to be opposite. What's the only way to get a positive number? If I multiply two negatives or two positives. But if they're both positive, I'm going to get a middle term, aren't I? And if they're both negative, I'm going to get a middle term, aren't I? So do you see that we cannot factor this then? We can't. Okay? Now I say we, meaning Algebra 2 students. In college algebra, in the other class that I teach, the college algebra class, we find out how to factor this. It's not hard. Okay? But it's not something you're ready for. Respectfully, it's not something you're ready for. Does that make sense? It's not. I mean, I could show it to you right now, but it won't make sense because of something we get to later on in the semester. No, that's not even true. It's in second semester that we get to it. Then it'll make sense. And if you'll remind me, then I'll show you. But I just don't want to overwhelm you right now because we're already doing a lot today, aren't we? Okay? All right? So, do you see why sum of squares is my favorite? Yeah? Okay. All right, what about this one? Difference of cubes. Well, what's this going to look like? Subtraction. What does this mean? What's a cube?
The 3.
So if a square is what times itself equals that number, what's a cube?
What times self?
Times itself, right? What times itself times itself. All right? So this is the difference of cubes. So we need to think about what times itself is x cubed. X, right? X times x is x cubed, right? What times itself is 27? 3, right? Now, to help you out, not the people watching this online, right now, but to help you guys out, look over here on the board. Do you see that chart that I wrote for you up on the board? Okay. The first column is x's. I just wrote 1 to 12. And the second column is x squareds. So all of the numbers in those columns are squared numbers. And then the third columns, I've got x to the third. Those are all cubed numbers. Okay, do you see how I have 27 on the same row as 3? Because 27 is the cube of 3. You do not have to have that memorized. Because first of all, you could create it really easily, couldn't you? Okay? But what I want you to do is I want you to be able to recognize numbers. I want you to see the number 512 and say, oh, that's something. I know 512 is something. Look up on the chart. 512. Yep, there it is. It's the cube of 8. Does that make sense? Yes? Okay. So keep that in mind. That, like I said, that's going to stay up there. It's for you to refer to it. But you could easily make it yourself, couldn't you? Okay. So let's go ahead and talk about this difference of squares problem. Now, when we did difference of cubes problem. When we did difference of squares, we got 2 binomials, right? Difference of cubes is going to be different, okay? You're going to get a binomial and what? Ooh, trinomial, okay? A binomial and a trinomial. The first thing we're going to do is find the binomial. Because once again, I'm not teaching you a formula. I'm not making you memorize a formula. I'm teaching you a pattern. Do you see the difference?
Yes.
Okay? So, let's figure out the binomial first. To figure out the binomial, I take the cube root of this. And what did we say that was? X. And then we take the cube root of this. And what did we say that was? 3. Okay? Notice what I didn't put in.
You didn't put X.
I didn't put a sign, right? I'm going to leave that out for just a second, right? So I'm going to use the binomial to get the trinomial. Okay? Here's the pattern to get the trinomial. Take the first term and square it. What do you get? X squared. Take these two and multiply them together.
3.
Take the last term and square it.
Oh, came out.
Do you see why I want to get the binomial first?
Yes.
Because the binomial takes us to the trinomial, right? Now, here's the thing about the signs. The signs are also a pattern. Okay? What's the sign in the problem?
Minus.
Then that's the sign in the binomial. The next sign is the opposite of that. And the last sign, always plus. Always plus.
Always plus.
Yep. Okay. You think you can do another one?
Yeah.
Even if it's harder?
Good. I'm not going.
Now, my first thought when I see a problem like this is there a greatest common factor? Right? Because if there is, I want to get it out of there first because that'll make the numbers easier, won't it? Okay? Nope.
No.
Right? Well, think about 64. What's the cube root of 64?
5 Wait. It's 4.
It's 4, right? It's 4. 64 does have a square root of 8. I agree with that. But remember, we're talking about difference of cubes, so we have to think about cube root of 64. So what times itself is 64, and that's 4, right? What about 125? So I've got my binomial, and I've got my trinomial, right? So let's fill in the binomial first. What goes in the beginning of the binomial? 4x squared, right? Because what times itself is x to the 6th. X squared. Does that make sense? X squared times x squared times x squared is x to the 6th. Right, what goes in the second term of the binomial? 5y. Okay, 5y. Okay, you ready? Trinomial. How do we get the first term in the trinomial? Square this one. So what's 4 squared? And what's x squared squared? X to the 4th. Everybody okay? How do we get the second term in the trinomial? So what's 4 times 5? 20. And then I have x squared y. Right? Because when I'm multiplying those two together, I just get x squared y. Right? Okay. And then how do I get the last term in the trinomial? Square this one. Very good. So what is it? 25 y squared. And how do my signs go?
Minus plus plus.
Because the first term is the first sign is the one in the problem. The second sign is opposite. The last sign,
Always plus.
always plus. Now, can I tell you some really good news about sum of cubes? It's not the same good news as sum of squares. Okay? It's not the same news as sum of squares, but it is really good news. Okay? Because of how I taught you difference of squares, you already know how to factor the sum of squares. Because guess how the pattern is?
The same.
The same. So guess what I get?
Binomial.
Very good. Let's fill it in then. What is the cube root of 216? Look up and find 216 and scoot over. What is it?
5.
Try one more time. Yep, 6. So 6x.
Yeah.
What's the cube root of 343? 7, right? Look up at 343 and then scoot over to the x. What is it? 7. What goes in the beginning?
A plus.
Almost. 36x squared, right? So square this one. How do we get the middle term?
42x.
42x. Multiply those two terms, right? Whoops, 42x. And then how do I get the last term?
You square that.
Which is
41.
49. Guess what the pattern of the signs is?
Plus minus plus.
Same as the problem. Opposite. Always plus. Yes?
Yes.
So all the ones that we've done so far have been what? Easy? Okay, that makes me happy. But what else? How many terms are there? 2, right? These are all binomials, right? Now remember, like I told you, there are special cases that you have to recognize. You have to recognize that it's a difference of squares or a difference of cube or sum of cubes, right? Now, it might seem weird to you, but the next special case that we're going to talk about is factoring by grouping. And factoring by grouping actually has 4 terms. Why do you think some people think that's weird?
Because it's more.
Because we went from 2
4.
terms to 4 terms, right?
3.
We skipped 3. We're doing 3 all tomorrow.
Okay.
Does that mean it's really hard?
No.
No, it means it's the most common. I don't want to spend the most time on it.
Right.
Does that make sense? Okay. So the thing about factoring by grouping is even though there's 4 terms, when we factor by grouping, we pretend there's not. We factor by grouping, so we group them into the first 2 terms and the last 2 terms. And as I'm doing this problem, I'm just ignoring the last 2 terms when I start. And I say, self, what's the greatest common factor in the first 2 terms? X squared, right? They're both divisible by x squared, aren't they? If I factor out an x squared, what's left? What's left when I divide x to the third by x squared? X, very good. What's left when I divide x squared by x squared?
X.
1, because anything divided by itself is 1. Okay? Now, can I do anything else with this right now? No? So now I ignore the first 2 terms and I just look at the last 2 terms. What are both of these terms both divisible by? I have to factor something out. And what are 2 terms always both divisible by? 1. Okay? Excuse me. So if I divide out a 1 from x, what am I left with? X. If I divide 1 by 1, what am I left with? 1. Now I look at both again, and I start over. I have this term and this term. What are both of these terms divisible by? What do these 2 terms have in common?
1. X.
Don't they have an x plus 1?
Yeah.
Don't they both have an x plus 1? So if I factor out an x plus 1, what's left? X
Yes.
squared
X squared plus 1.
plus 1. And that's the answer. Now, keep in mind that that's the easiest one I could possibly give you. Right? It's the easiest one I could possibly give you. We did that first so we could build our confidence and know our steps. Okay? So what about a problem like this? Oh, we panic now? Is that what we do?
Is that a minus or a plus?
This is supposed to be a minus. Please forgive me for messing up. But keep in mind we're doing the same steps, right? Just look at the first 2 and then just look at the second 2. So if I ignore the second 2 and just look at the first 2 to begin with, what's the greatest common factor between these 2 terms? What are they both divisible by? 2x squared. That's exactly right. Okay? What am I left with if I divide this first term by 2x squared? Just an x. What am I left with if I divide the second term by 2x squared? 5. Just 5, right? Because x squared divided by x squared is 1, and I just have a 5 left, right? Can I do anything else with this right now? Then we're going to ignore it. What's common in these 2 terms?
3.
A 3. What's left when I divide this term by 3? What's left when I divide this term by 3? Minus 5. What do these 2 terms have in common? What are they both divisible by? X minus 5. And if I divide each term by an x minus 5, what's left?
2x squared plus 3.
2x squared plus 3. So let's talk in general real quick about these 2 examples before I try to trick you on the last one.
Okay.
Okay? When you factor out something common, what has to be true about what's left? Not only the signs, but don't they have to be exactly the same? Everything has to be exactly the same about them, right? Because I need to factor it out in the next step. That means these 2 things have to be the same. These 2 things have to be the same, right? Everybody okay with that? Okay, then let's do this one. It looks really easy, right?
No,
Oh, it doesn't?
kind of.
Kind of. Okay, that's fair. So what do I want to do first? I want to group them, right? Group the first two and group the last two. What is common in the first two terms?
Square.
X squared. If I factor out an x squared, what's left? X minus 1. Can I do anything else with that right now?
No.
No. Now just look at the last two terms. What's common in the last two terms? A 4. I agree with, but if I factor out a 4, what's going to be left? Negative x plus 1. Are those going to be the same then? Then what do I have to factor out? A negative 4. Very good. If I factor out a negative 4, what's left?
X plus 4.
X-
Or
X minus 1.
Oh,
Or that, yeah. Oh, okay, that's fine. That's fine. Okay. Now, what is common in these two terms? X minus 1. If I factor out an x minus 1, what's left?
X squared minus 4.
X squared minus 4. Now, I have some bad news for you. If you put this in your computer as your answer, it will tell you it's wrong. Because it's not factored completely. Why?
You still have
Negative
X
4
squared,
times
maybe?
1 would be positive 4.
What is
They have to be
this?
opposite.
No, what is this?
Because they're both even.
What is it?
Minus.
It's the
Minus.
difference of what?
Cube.
4.
Squares. Isn't x squared a square?
So,
Isn't 4 a squared? So we have one more step we have to go on this problem. It's not that we did it wrong, it's that we're not done yet. Okay? All the other ones we were done because there was nothing else we could do, right? There's no other thing we could factor. This right here, you've got to be able to recognize is the difference of squares. Like one of these problems that we did earlier. Do you see what I'm saying? So I have one more step to go. That's this one, right? I just copied that one down. How do I factor the difference of squares? X plus 2, x minus 2, right? Square root of the first one at the beginning, square root of the last one at the end, and what's true about the signs? Opposite. Okay? Don't let yourself get tricked by this. Okay? Now, if you get this and put it in and it tells you it's wrong, rule number 1, don't panic. Look back and see, wait, did I not finish? Is one of these not factored all the way? Does that make sense? Okay? Any questions about greatest common factor? Difference or sum of squares? Difference or sum of cubes? Factoring by grouping. That's a lot, right? That's a lot of special cases in one day, isn't it? But were any of them difficult? No, the hardest part is remembering the patterns, right? Okay, remembering the patterns. So that's what we're going to work on today.